Hi everyone. So in this video I want to talk about bubbles, and interestingly there's some information here regarding bubbles. But you know what? I wanted to, because I wrote down some stuff. The other day, I was tripping out as I was watching a space documentary, and I wrote down bubbles filled with different gases to monitor if they will still create a perfect circle or another shape, like Saturn with a particular shape on the polar. So let's look at that. So that's planet Saturn. Oh yeah, shape on polar. That hexagonal cloud pattern. So it looks like this. And scientists have actually been able to figure out how to mimic this here on planet Earth. And can you guys see that it's not perfectly round, like a perfect circle? It's an hexagon. Ooh, and then there's a picture there, and I really don't want to share that one, the GIF file, because my video could get like brought down or whatever. It will not be accepted on YouTube for whatever reason if I play it for a long time, especially like a video. So anyway, yeah, so on Saturn, planet Saturn, there's this hexagon shape. But although it's not a bubble, but I think I was watching like a documentary about space, and I noticed this. So I thought about, and I theorized, I hypothesized that what if bubbles are only formed in a perfect round shape with oxygen only. So I'm creating this video for those of you who like to experiment, to try out, to try different experiments, and like the first one will be a room filled with a different type of gas, and then having a bubble machine there bubble within the room, bubble machine. So you guys will have some type of bubble toy, okay, within the room, because all it is using, or the way that the bubble maker works, it has a little propeller, and then it has a liquid at the bottom, soapy liquid, and then as these round things, so the air basically mimics someone blowing through like a circular object, like, you know, those ones that you dip into with a little stick and then you blow it. Well, basically a bubble machine is similar, but it uses the fan, and yeah, some of them are electric and then some of them are house powered. So anyway, so having one of these and trying different gases, so different gas, so the rooms will be entirely filled with these different gases, just to see if the bubbles will come out perfectly round in shape. So I'm going to type in bubble close-up so you guys can kind of see what I'm referring to. So it's perfectly round. Okay, there's a bunch of perfectly round bubbles. And yeah, I just wanted to test this out. So there's, here it says there's hydrogen, nitrogen, oxygen, which is the stuff we breathe in, and then there's fluoride, there's chlorine, there's helium, and I don't even know how to pronounce this one, neon, argon, krypton, hex, or xenon, radon, compound gases. Oh, maybe, well, look, it says gases in the air. There's oxygen, nitrogen, argon, carbon dioxide, and I think that's what's in the air. Well, we, you know, the stuff that we breathe in. But it's, what the heck? It says makes up about 21% of the atmosphere. Oxygen. I thought we were breathing 100% oxygen, but apparently we're not. It's nitrogen. It says makes up about 78% of the atmosphere. So I don't really know what's going on there. But anyway, so yeah, just figuring out which gases can be used, and then, you know, presenting them inside of a room, filling it completely, entirely, with the gas with no way of escape. So it's going to be a vacuumed chamber of some sort. with any particular gas, okay? Just to monitor if the bubbles are perfectly round or not. But I'm going to read this. It says bubbles. My first search, it says bubbles are thin films of soap or other liquid that trap air or gas, often seen in soap solutions or boiling water, and are a popular toy for kids and adults alike. So maybe it has been tested, which is perfectly fine with me, but I just wanted to get this out of my mind. Okay, here's a more detailed look at bubbles, what they are. Bubbles are essentially a soap film, a thin layer of soap and water that surrounds a pocket of air or gas. How they form: when you blow air into a soapy solution, the air gets trapped within the soap film, creating a bubble. Why they pop. Bubbles pop when the soap film breaks down, often due to water evaporating, or the film becomes too thin to support the air pressure. I didn't understand. I didn't know that there was a difference, or a difference in air pressure, if at all. So, the differences in air within a bubble or outside of it. I didn't know that. It says air pressure. I thought it was constant, like equal. But if a bubble is formed and there's air pressure, doesn't make sense to me. But anyway, I guess it's not really important for this video, but it could be important for those who study bubbles. So yeah, that would be a completely different video that I would have to create, or I just don't know. I don't know how that could be useful, that information. Unless possibly you people want to collect more air molecules than you would normally collect apart from bubbles. So if it is true that bubbles collect more air molecules, then I guess bubbles can be introduced when attempting or trying to collect a ton of like compressed air, you could say, as an example. But my personal reason for a for a balloon to pop will be more in line with the water evaporating concept here, and not anything regarding air pressure. But I could be wrong, and I'm not afraid to be wrong, or I just don't understand what this air pressure means to me entirely. So I would have to educate myself on that regard a little bit more to understand that. But anyway, so yeah, like in other words, I don't think a composition of a bubble has anything to do with air pressure. But you know, like I said, I could be wrong. Anyway, soap films. Soap films are made of soap films are made of 3 layers: soap, water, and another layer of soap. It says soap films. Soap films are made of 3 layers: soap, water, and another layer of soap. I don't understand that. Oh, okay, I get it now. So there's the soap, the water, and then the soap, which create a bubble. So, so there's a droplet of water. I'm sorry, yeah, a droplet of water that has soap within it. It would mean that the soap layer will be on the exterior. So there's a division there. So that soap liquid or substance could be controlled and manipulated, from what I'm gathering. So if there is let's say like in space, like in the ISS, International Space Station. If there is water trapped inside of a, I don't know, maybe in the ISS, or because I don't know if water acts and behaves the same way here on planet Earth when in light of when we look at a straw with some water that is trapped within it but doesn't flow out. It stays within the straw. Which is very weird and unusual behavior for water. Anyway, because straws are clear, so I've witnessed that before. And so anyway, so if somehow scientists could duplicate that, and a piece of iron, a wall of iron, were to make contact with one side on one edge of the straw, that would mean, especially if the water had soap in it, that would mean that the soap would travel, the soap film would travel to the other side of where there's oxygen, or is it equally mixed in there? And if so, then the soap layer is only for bubbles, because it requires energy for soap to be divided from the water. But if it does it naturally, that's kind of interesting information, especially when it comes down to water distilling and purification and all that. This information could be useful towards that. Towards that. But I don't know, I would have to experiment and fuck around with it to like really provide more feedback. But anyway, soap molecules have two ends: a water attracting end and a water repellent. Oh, so it does act like a magnet, which helps them form the soap film. Excuse me. A water attracting end and a water repelling end, which helps them form the soap film. So on a magnet, there's the negative side and then the positive side. So that's kind of interesting, especially if you guys are thinking about creating like a generator from water, but it would include soap. Because it says right there specifically that there's a water attracting end and a water repelling end. So this soapy liquid is attracted to water, then technically, instead of flowing down a slope, it could technically go upwards if there's fresh water above, I don't know, let's say a droplet of water. So you have 2 droplets of water, one fucking fresh and one with soap and water. So that means that would mean that that the soapy water will travel. It will be attracted to the fresh water. Now, if that doesn't work, I would perform a different test and try adding the same sequence, but instead adding another fresh droplet of water right across the other droplet of water from the droplet of soap and water, because one end attracts while the other end repels. So it could create motion similar to magnets. And maybe that's all that's going on there when we think about a magnet. But if that was the case, then bar soaps would technically act like a magnet, but not necessarily, not entirely. So anyway, I'm going to continue reading. Just some food for thought, that's all. Mathematics of bubbles. Soap bubbles are a physical example of the complex mathematical problem of minimal surface, assuming the shape of least surface area possible containing a given volume. So let me read that again. Okay. It says mathematics of bubbles. Soap bubbles are a physical example of the complex mathematical problem of minimal surface, assuming the shape of least surface area possible containing a given volume. That's a lot of information to process. Honestly, it is. Oh, Jesus Christ. Like they say, if it's not one thing, it's another. So let me see here. I need to read this again. This is... Oh no. So there's a lot to learn about bubbles. So, it's simple for someone to say, oh yeah, just fucking, create a room filled with one particular gas and then have a bubble machine in there. To create, hundreds of bubbles. But yeah, we all know there's more to it than what people assume, especially for those of you who study bubbles. And other stuff regarding bubbles. So, and I was watching a documentary on YouTube regarding bubbles, and there is some people out there who study bubbles, which is pretty cool because they're everywhere. Everywhere. Anyways, so I'm going to read this again. It says mathematics of bubbles. Soap bubbles are a physical example of the complex mathematical problem of minimal surface. Assuming the shape of least surface area possible containing a given volume. Assuming the shape of least surface area possible containing a given volume. I don't understand that. volume in the bubble layers. The bubble layer, I mean, I don't know. Or is it the same? I don't know. This is very. I would have to do more research on this to understand. But anyway, bubbles in different contexts. Science experiments. Bubbles can be used to demonstrate scientific principles like surface tension and air pressure. Which I have no idea about this. Neither the surface tension or the air pressure. Toys. Bubbles are a popular toy for children and adults with various bubble blowing devices like wands, machines, and guns. Party favors. And the guns is pretty much a bubble gun. Obviously. Party favors. Bubbles are often used as party favors for birthdays and other celebrations. Art and entertainment. Bubbles can be used in art, installations, and performances. Fictional characters. Bubbles is almost the name of a character in the Canadian television series Trailer Park Boys and the Powerpuff Girls. Michael Jackson's pet, Bubbles, was also the name of the common chimpanzee that Michael Jackson owned. When he was alive, of course, because he passed away. If you guys know anything about Michael Jackson. But anyway, so yeah, pets and cartoon characters are named after the word bubbles in plural form. Making your own bubble solution. You can make your own bubble solution using dish soap, water, and glycerine or corn syrup. Okay, no wonder my bubbles don't last very long. I added the dish soap and the water, but never the glycerine or corn syrup. Interesting. Oh, and it seems like it's in daily moisturizing lotion. Moisturizes Pure glycerin moisturizes dry skin. So there you have it. So add some lotion in that motherfucking solution, kids. Naturally hydrating. Add to skin and hair products. So, just food for thought. Don't talk about it. Just do it. Just do it. Especially if you're going to get it in trouble over it. Like, no, what happened to all my skin and hair product solution? Because if these people find out, but yeah. Anyway, this sums up my video. So I hope you guys like this video. And it would be super crazy if bubbles behave differently in one particular concentrated form of gas, a gas environment. And by that I mean the gas in air format and not a liquid, obviously. So anyway, yeah. So yeah. I mean, well, and I guess you guys could all of you guys could before you guys have money, you guys could do these experiments or whatever. You guys could test each other and tell other people what type of shape they will witness besides a perfect circle. This sphere thing. Especially if the answer is already discovered. So this will be great for school experiments, and it will be some cool school experiments. um, because kids love bubbles, even adults. I love bubbles. Everyone loves bubbles. So if somehow you people out there could manipulate their behavior or their shape in one way or another, it would just be super entertaining. And then I guess you guys could go into more complex studying regarding other matters if it proves to work that a different gas will cause a bubble to be formed in a different shape naturally, like a bubble. Then you guys could you guys would be able to trip out on that, and just uncover or discover different fields of education. You guys could dive deeper in other mysteries of this life. So anyway, yeah, so good luck, and if nothing happens, then nothing happens. But if something does happen, that's when this will all be very fun and exciting for everyone. Now will it? Now will it? Hello, can I get an amen? Can I get an amen? Everyone together. 1, 2, 3. Perfect. Enjoy making your bubbles, people, and your bubble solutions.